Hi, welcome to Nomis Academy. In this video, I'll be teaching you the application of differentiation. Yes, differentiation is applicable in so many fields, especially engineering field. And a question like this could come out in trying to understand a circular wheel, a circular object, or a circular engine that have to do with diameter, radius, the circumference of the wheel. So, question like the radius of a circle is increasing at the rate of 0.5 centimeter second. Find the rate per second rather. Find the rate at which the area is increasing when the radius of the circle is 7 centimeter. Remember that when we talk about differentiation, we are definitely talking about the change that occur in one variable with respect to the change that occur in another variable. So what variable are we talking about? From the illustration given in the first instance, the radius of a circle is increasing at the rate of 0.5 centimeter per second. So it is about the radius of the circle and the time taken for the increase to occur. So it's at the rate of 0.5 centimeter per second. So the rate there is the change in the radius and time. Change in the radius and the change in time. Now the question now asks, find the rate at which the area is increasing when the radius of the circle is 7 centimeter. So they are now asking questions on the change in the radius and in the area of the circle. So how do we get this question solved? With the use of our formulas in differentiation, we'll be able to solve this question. So let's get into the solution. Solution. So let A be the area of a circle of radius r. So let's say A is area of the circle and the r is the radius. So firstly, let's interpret the r dt. Remember the r dt. So what is the r dt? So the r dt is 0.5 centimeter per second. The r dt, that is the change in r all over the change in t. The r dt is equals to 0.5 centimeter per second. So while the A, we know that the formula to calculate A is pi r squared. So what do we do now? Let's find the A, the r. The A, the r, that is to differentiate A with respect to r. So the A all over the r is equals to, using our simple formula of differentiation, since we have pi r squared, so this becomes 2 multiplied by pi r2 minus 1, and that gives us 2 pi r. 2 pi r, because this is 2 minus 1 is just 1, so we have 2 pi r. So the A, the r is equals to 2 pi r. So you remember our chain rule? So using chain rule, we can say that the A all over the t is equals to the A all over the r multiplied by the r all over the t. The A all over the t, remember why we are choosing the A all over the t, because we want to know the change that occurs with the area of the circle and the time. So the question says, find the rate at which the area is increasing when the radius is now So A is equals to pi r squared. So what is now the radius? The radius, find the rate at which the area is increasing when the radius of the circle is now 7 centimeter. So now that the radius is 7 centimeter, we'll put in the value of r 7 centimeter here. 7 centimeter multiplied by 0.5 centimeter all over second, 1 second. So I can say this is equal to 14. 2 times 7 is 14 centimeter. So that gives me 14 centimeter multiplied by pi, right? Now multiply by 0.5 centimeter all over second, right? So if you multiply 14 by 0.5, 0.5 is 1 all over 2. 0.5 is just 1 over 2. So when you are multiplying anything by 1 over 2, you have to find the half of that thing. To find the half of that thing. So 14 times 0.5 is definitely 7. Is definitely 7. So that will be 7 multiplied by, now what is pi? Remember, pi is just 3.142. 3.142. Don't forget we have a centimeter here. So 3.142 multiplied by 1 all over second, right? So all over second. So everything is per second. So we now have 7 multiplied by 3.142. To make it simple, you can just say 7 centimeter multiplied by 22 over 7, because that is what 3.142 is. Now, multiply by, we have a centimeter here, 1 centimeter per 1 second, per 1 second. So 7 cancels 7, we are left with 22. Centimeter multiplied by centimeter is centimeter squared per second. So this is the A, the T, the